Okay, so Charles's law helps to discuss changes in volume and temperature when we have constant pressure and the number of moles. Okay? Charles's law is V1 over T1 is equal to V2 over T2. And this is a direct relationship. As the temperature increases, the volume increases. So if temperature increases, the volume, ooh, that's ugly, increases, but we'll work with it. All right, so let's take a look at this problem. Let's take a look at this problem, and let's go through and see what we have. How hot will a 2.3 liter balloon have to get to expand to a volume of 400 liters? And we assume that the initial temperature of the balloon is 25 degrees Celsius, which is room temperature. Whenever we're doing gas laws and we have to do temperature problems, we always have to convert Celsius to kelvins. And that's just 273 plus 25, which is 298 kelvins. Okay, so what do we have? We've got V1 is equal to 2.3 liters. We've got T1 is equal to 25 degrees Celsius. And we are given V2, which is 400 liters. And we want to know what is T. So we're looking to find out what is T2. Well, to help us figure out if our answer is correct at the end, let's look at our volumes. Our volume increased because we're going from 2.3 liters to 400 liters. So that means that our temperature must also increase because this is a direct relationship. All right, it's directly proportional. So we've got V1 over T1 is V2 over T2. And now we've got to get T2 by itself. So what do we do here? If we multiply both sides by T2, these guys cancel over here. And now I get T2 times V1 all over T1 is equal to V2. That's not helpful. We're not done. We still have to get T2 all by itself. So what we need to do is, we need to do something with these two guys right here, V1 and T1. So if we take them and we invert them and multiply both sides by the inverse, then we can figure out what T2 is. So what do? I take T1 over V1. This is what I mean by multiplying by the inverse. Right? And let's take a look at how those cancel out. So V1 cancels with V1, T1 cancels with T1, and I'm left with T2 all by itself. Okay? So T2 now is V2 times T1 all over V1. Now we can plug and chug. Okay? So, remember that our temperature is 298 kelvins for T1. So V2 is 400 liters. T1 we converted to 298 kelvins. And V1 now is 2.3 liters. 2.3 liters. Right? Let's make that prettier. Okay. It's kind of prettier. 2.3 liters, and when we plug all of this in our calculator, how many significant figures should we have? Well, I've got 2 here, 1 here, and if I look at my 298K, or my original, which was 25 degrees Celsius, that was 2 sig figs. So our final answer should only have 1 sig fig. When you plug all of this in your calculator, however, you get 5, 1, 8, 6, 2, oh, I'm sorry, 8, 6, no, I put that in wrong. 5, 1, 8, 5, 1, 8, 2, 6. So if we want to have just one significant figure, we have to round up here to the 50,000 and put in zeros as placeholders. All right, 50,000 K. Does that make sense? Our volume went up by a whole lot. So our temperature should go up by a whole lot. So that is our answer, 50,000 K. And if we wanted to, well, it wouldn't make sense to convert that back to Celsius, because if we wanted to convert it back to Celsius, the number would still be, if we're rounding up to one significant figure, we would still end up with 50,000. Because 50,000 minus 273, that's 49 and change, it still ends up being 50,000. All right. Oh, what did I say? 50,000. Just in me. When I subtract 273 from 50,000, since I have to round it back up to one significant figure, it's still going to be 50,000 degrees Celsius.